Part B. Soil moisture. Soil moisture. It is an important part really, as additional water to the soil causing a gradual filling of its pools by water, and consequently air driven out and water go downward under gravity force. Therefore, additional more water should lead to an increasing of saturation depths until covering all the soil profile depths, and then drainage takes place. Movement of water in soil refers to acting in different potential gradients such as barometric potential, osmotic potential, gravity potential, heat potential, and hydrostatic potential. Movement of water into the plant roots depends on two mechanisms. First mechanism refers to the high concentration of salts inside the root cells compared to the low concentration of salt in soil solution, and so movement into roots takes place, while the second mechanism refers to the diurnal evaporation process of water from the plant leaves, and so potential gradient is transformed, causing a movement of water from the adjacent cells and consequently from the soil solution to plant roots. Figure on moisture characteristics for different soil textures. Show by yourself the available water percentage under different soil textures. Soil moisture contents in each soil refer to its properties under standard conditions, which is practically changing under field conditions by time, gradually after irrigation, and so should be taken into consideration when taking decision of irrigation. Gravitational free water occupies the macro pools of soil and drains away under the influence of gravity, with the soil water potential at this case will be less than 0.1 bar. Capillary water is the part which holds by surface tension of soil particles. The upper limit is when drained all the gravitational water, and the soil is then known as at its felt capacity case, which is normally considered the upper limit of the available water, while the moisture equivalent is the soil moisture content after centrifugal saturated soils at speed equivalent to a force of 1000 times that of gravity. Please, my dear, note that as the thickness of water filmed around soil particles decreasing gradually due to the evapotranspiration processes than absorption, plants beginning to showing wilting symptoms during most of the daytime, especially on the hot midday time. At this point, plants are not completely dead, but still remaining in wilting condition, and soil moisture content at this stage is known as permanent wilting point. Please, my dear, as soil moisture decreasing more below its permanent wilting point, and so water will be so hold firmly around the soil particle. In this case, moisture will be absolutely unavailable to plants and known as hygroscopic water capacity. The available water. Optimum growth of plants takes place in most normal conditions when soil moisture content is kept around its field capacity and is affected with decreasing water potential from field capacity to permanent wilting point. Hence, it can be determined in soil layers by following the enclosed equation. There is a critical moisture tension depends upon the soil characteristics and plant species, which is significant decreasing in plant growth starting to be noticed under this level. Many researchers define these critical points by 0.5, 0.65, and 0.8% of available water for clay, loamy, and sand soil respectively, which is expressed as readily available water. Movement of moisture in soil. Logically, movements of soil moisture through a given volume of soil take place through its pore spaces. Type of this movement should be discussed from 2 points of view, such as how this movement done through the drainable pool as a result of gravity force, which is known as movement in saturated conditions, or that moving done through the non-drainable pool in the presence of air interference, which is known as movement in unsaturated conditions. In saturated soil, water movement takes place throughout the soil pool space that's containing little of air. because it is so difficult to imagine removing all the air from the soil column. Anyway, we'll assume that flow takes place through a completely saturated soil. According to Darcy's law, velocity of water flows through a column of soil is directly proportional to the difference in pressure head and reversely proportional to the column length, such as illustrated before. Schlechter deduced different variables of soil characteristics and developed a formula, which is including transmission constant K, which is a function of soil properties. Dunkel recognized both soil structure and soil particle shape and developed a formula, as shown. Values of n in previous Dunkel equation varies from 2.3 for round particles to 2.5 for disc-shaped particles. Take in consideration that most of soils contain various particle shapes, and so n value is usually taken as one absolute number. On the other hand, Richards added gravity constant and a relative absolute viscosity vector, which is known as modified Darcy formula. Movement of soil moisture in unsaturated conditions. An unsaturated soil is one in which the large pools are filled with air, and consequently water movement is closely dependent on a numerous number of air-water interference. Movement and distribution of moisture at this case may be horizontally, vertically upward, vertically downward, and or radial pattern. Exactly, it is a mix. My dear, height of capillary rise equation is illustrated in front of you. The height of rising water in soil pools is inversely proportional to the diameter of these pools, and generally capillary movement downward should be slightly faster than either upward or horizontal movement. The amount of water which passing at 1 unit of time through a unit area of an imaginary soil plan surface perpendicular to the direction of motion is known as capillary flow rate or capillary strength. Soil texture and structure effect on soil capillary conductivity as they influence on the number, size, and continuity of soil pools. Soils can be arranged in the following order with regard to its decreasing on its capillary conductivity: clay, clay loam, sandy loam, loamy sand, and sand. Capillary conductivity is affected also by soil moisture content, as it is increasing up to the maximum at or near saturation, and then decreased rapidly by decreasing the moisture content. Movement of soil moisture in vapor phase occurs as a result of vapor pressure differences within the soil from the higher to the lower vapor pressure spots. Extraction moisture by plants. Generally in homogeneous soil, greater development and distribution of plant roots take place in the upper soil layer than elsewhere, and normally influence on the pattern of moisture extraction from the soil profile. Please, my dear, look to the enclosed figure, which showing the extraction pattern of moisture by plant roots. My dear, water deficit effect on all aspects of plant growth, as some physiological processes are highly affected, while others are less. Look and follow by yourself. Irrigation requirements of application water in cubic meter indicates the volume of water which should be applied to a soil to increase its initial moisture content of a soil layer to 100% level of field capacity, and can be calculated easily by the enclosed equation. Efficiency of a chosen irrigation method and leaching fraction should be taken into consideration for obtaining the practical gross irrigation requirements as shown in the enclosed equation. On the other hand, water rotation or cycle irrigation application intervals in plot area is the frequency in days between the irrigation time and can be calculated by following the specialized equation. Water balance is the difference between input and output quantities of water by different resources. Hence, it can be classified such as overall water balance of soil water, and water balance of groundwater, as shown in the enclosed equation. Parameters of water balance equations. Note the accuracy, my dear. Measurements of soil moisture. There are 9 methods which can be used to determine the moisture content in soil. Some of it are usually used in laboratories, where others can be done directly and faster in the field. Gravimetric method. It considers the direct, simple, and standard one. Follow by yourself, my dear. Electrical resistance blocks. Idea. Depend upon the principle of changing resistance of an electrical current between two electrodes buried in soil will depend upon its moisture content. Please refer to the enclosed figure, which showing the resistance blocks with conductance meter. Two main types of blocks are in current use, such as fiberglass blocks and gypsum blocks. Moreover, two types of conductance meter are used for reading the resistance values of moisture blocks and its change, such as Coleman meter and Bayesian bridge. Tensiometer method is a simple apparatus consisting of a tube with a porous ceramic and cup filled with water and buried in soil at the desired depth and connected to a manometer as a vacuum gauge. This is a rapid and easy method for determination the soil moisture percent in the field, taking consideration that the tensiometer reading indicating only the soil moisture tension and need for a special calibration curve for the particular soil. Please follow the enclosed figure. Penetration resistance method is related to the required force to push an instrument through soil and is affected resistance by soil moisture. Take in consideration, please, that the instrument must be calibrated at this case to obtain an accurate relation between the penetration resistance and soil moisture content under each type of soil. Heat diffusion blocks or cells. This method is based upon the principle that the heat conductivity of a soil varies with its moisture content. There are 3 types of heat diffusion cells, such as porous flow, direct contact, and modified direct contact. However, the thermal conductivity cell is the most satisfactory and not affected by salt concentration soil up to 10,000 parts per million. Soil moisture sensors measure the volumetric moisture content in soil indirectly by using some properties of soil as an indication of moisture content, taking consideration that the sensors must be calibrated, while the absorption blocks method depends upon the moisture absorption phenomena of blocks from the adjacent site when installed in soil, and the soil moisture was then estimated from the change in weight of blocks. Neutron moisture probe depend upon the idea that the hydrogen atoms which containing in the soil water are effective in reducing the speed of moving neutrons and scattering them. According to this scattering and change in direction, some of the neutrons will return to a point near the artificial neutron source as slow-moving particles, which means that their number being a function of the number of water molecules containing in the volume. The neutron moisture meter consists of 2 main parts, as probe and counter recorder. The probe contains a source of fast neutrons and detector of slow neutrons, while the counter recorder is a battery and monitors the flow of slow neutrons. My dear, follow the enclosed figure which showing the neutron moisture meter. Time domain reflectometer, CDR, works as the same principle overlap. His technique is based on generating and pulsing an electromagnetic pulse along an coaxial couple to stainless steel rods embedded in the soil, hence determination the time of travel wave by the dielectric of soil, which is related to its moisture content. Please look to the enclosed figure. Dry soil has electric dielectric from 3 up to 5, while air has 1 dielectric, compared to water, which has 80 dielectric. Accordingly, the travel time along waveguides will be high at high soil moisture and be low at low soil moisture, refer to the enclosed equation. Effective length of waveguides and therefore the ability depth of soil for moisture measurements must be determined by the power of generated pulse by TDR, taking consideration that heavy clay soil requires less wave power than the lighter soil sector. Generally, there are many advantages can be obtained by using time domain reflectometer. My dear, it is easy to follow it by yourself. Multi-references. It is so easy and fantastic and can follow by yourself. Continue references, my dear. More references also. Additional references, my dear. Continue. More and more, follow by yourself. More references, my dear. Follow it. References also, my dear. Follow it by yourself. Goodbye.